In this lecture, we're going to talk about methods. Methods are a way for us to break our program down into smaller, more reusable pieces. And a few weeks ago in the reading, you'll remember we talked about different approaches to problem solving as they relate to programs. One of those solutions was called top-down program design, which involves taking a complex problem and breaking it down into smaller pieces, and then taking those smaller problems and breaking them down into even smaller pieces and so on. And methods allow us to do this. And we can think of methods as really tiny programs that we can utilize and combine in unique and creative ways to go ahead and build bigger programs. And in this lecture, what we're going to do is look at how to build our own methods, because a lot of times the functionality that's provided by the Java programming language doesn't necessarily do everything we want it to. And so this week and next week, we're going to look at how we can add to the base functionality in the Java language. And this is pretty common in any programming language. Why do we use the term method? Well, Java is an object-oriented programming language, and we want to use the term method because really methods are these discrete packets of functionality, but in the case of specifically an object-oriented programming language, methods usually represent the behaviors that are associated with an individual object. We'll take a look at some of that in a second. And we'll talk more about object-oriented programming next week. One of the things to keep in mind throughout all the lectures this semester, and this is just the way the book represents it, so it's the way we're going through this material, is that we're kind of ignoring the fact that Java is an object-oriented programming language, and we're doing or taking a process called procedural type programming to our approach to learning code at this point. But next week we'll kick in to learn how to make our own objects, and hopefully a lot of things will get a little bit clearer at that point. Anyway, if you were to program in other languages, you may see the term procedure. That term pops up in Visual Basic. You may also see the term function. That actually turns up in Visual Basic too, but like in languages like C, these are basically terminology that all stand for the same thing, similar to methods. So if you hear me say the term method, procedure, or function, I'm really talking about the same thing. They serve the same basic purpose. There is some nuance to the different words and specifically what they mean, but the reality is, at least for this week's lecture, they're somewhat interchangeable. And again, we're only going to look at methods this week and not at how they provide functionality to objects. And again, just kind of because the book presents it that way. So the term method is going to be our small packets of code that we're going to build. So we've used methods before, and if you take a look at the code in yellow here, println is probably the most common method that we've utilized up to this point. It provides some functionality to us related to the system.out behavior. Another method we've used is the math.pow method, and notice that takes 2 and raises it to the third power. So we're familiar with this idea of using pre-written packets of code, and you'll notice that the dot operator is what allows us to tie a pre-written piece of code to a specific object. We're not going to actually need the dot operator this week because we're just going to write methods that run on their own in what's called a static context. And finally, you'll see the equals method, which we've used before. And remember that when you compare two strings, you have to use the equals method. You can't actually utilize the two equals signs. So those are just some samples of methods that we've used. So we've utilized these, but now what's really nice is we want to learn how to create our own. A couple of notes about methods, and we'll clarify this as we go forward here, is that methods may or may not accept input. If we go back a slide, notice that all of the methods declared here in yellow have what is called parameter input. And notice that between the parentheses, the first item, println, accepts a single string parameter. So anything put inside of those parentheses is being passed into our method for processing. So the word yo is being passed into the println method for processing, and that means it'll get printed to the screen. 2 parameters are being passed into the POW method. We're passing in 2, which is the base, and then 3 is the exponent, and we'll send that into the method for processing. And then also notice that the equals method accepts a string for processing, and what it does when it puts that into the method, the string me is compared to the string stored in the variable input, and if they are truly equal, the letter M followed by the letter E, both in lowercase, then it would return true. So we can actually provide input to a method, and that input appears between the parentheses after the name of the method. Methods may or may not return a value that can be stored in a variable. So if we go back again, you'll notice here that the last two examples, math.pow, 2 to the third power is going to return an answer, and what I mean by return is I can take the answer generated by the POW method and I can store it into the variable answer. Notice I can actually have that method on the right-hand side of an assignment operator because it's going to pass a value back to the variable on the left. Same thing goes for the equals method here. Because it returns a value, it's actually going to take the value on the right, it's going to take the value, the string me, compare it to the value stored in input, and then it's going to generate a boolean of true or false, and then I'm capable of storing that answer into the variable same. The method at the top does not return a value. The method at the top, println, just prints to the screen. And I want to make a difference here. Printing to the screen is not the same as returning a value. When we say return a value, it means that the method returns something that can be assigned to a variable. In other words, the blunt way to put it is returning a value is data that is only meant for the machine to process further in code. If the information needs to be printed to the machine for the human, the computer does not consider that returning. It considers it an annoying process, I'm sure, that it has to do to make the person on the other end of the console happy. So remember, printing to the screen is not the same as returning a value. So as we talk a little more about methods and as you go through the reading, make sure you get the meaning of what it takes to return a value. And notice that I can assign the value that's generated by the method calls on the right of the equals sign, in this case the assignment operator, to a variable on the left in the second and third example. In the first example, I cannot because it's just printing out to the screen. So what's the anatomy of a method? Here's a little method I wrote called add2. It takes whatever parameter I pass into it and just adds 2 to it. I pass in 7, it returns 9. I pass in 11, I get 13. So it's a pretty useless method, but it's a good way to kind of demonstrate a simple mini program. And that's what this is. It's a small program. When we run it, we give it a number, and any number we give it actually gets kicked back to us with 2 added to it. So let's go through each component and look at them. So in yellow and in bold, you'll see each piece of the method. So the first item is called the visibility identifier. And this week, we're going to ignore what that means. We're just always going to type it so we get used to it. The idea here is later on there are actually some other visibility modifiers, protected and private. Those will be useful to you as we move forward. Next week we'll do a little bit with building our own classes, and we'll talk a little more about visibility modifiers. But for now, we just want to make everything public, and it really has to do with who has access to this code. And by making it public, we're saying, well, everybody has access to this code. Next week we'll look at some instances where we might not want everybody to have access to this code. So for now, declare it public, ignore it, just make sure it's always there, and we'll clarify that later. This is one of the drawbacks to using Java as our programming language. It's a very heavyweight language, and sometimes we need to take things for granted that they function and not really ask why, because we'll get to that later. So just bear with me. The next item is the static modifier. Because the way the book teaches this, we are building methods that are not attached to a specific instance of an object. In other words, if you have a car object and I say drive, when I set that behavior in motion on your car object's going to go up the road. My car object will stay put. Next week we'll look at how to tie methods to specific objects. In this case, we're looking at methods that provide functionality to our code without being tied to a specific object. I know that's confusing, and it's really odd the way the book presents this, but we'll just stick with it. So, just like I said on the last slide, if you're not sure why you need it, this week you always need static. And we'll talk about what static methods are more next week, because they're actually a very powerful feature of the language. So, yeah, we need public, we need static, and we're not going to worry too much about why they're there. Just always put them there. The third item in, you'll notice, is int. And int should be readily identifiable as a data type. And it's a standard data type, like double, float, car, even like string and some of these other object data types. This is called the return type. And in other words, if a method, which is a little program, is going to process data and then give us back an answer, in other words, it's going to return a value that we can store in a variable or print to the screen or further manipulate. Okay, because Java is a strongly typed language, we need to know what type of data the method is going to return. Because remember, every time you store a value into a variable, you need to declare what type of data is going to be put in that variable, right? Because you declare a variable to be of type int, then only ints can go in that variable. You can't stick a double in there or a character. It screws things up. So the same thing goes with methods. If your method generates a value, and that value is going to be returned for the user to keep using, we need to indicate the return type of the method. In this case, you'll notice that there's a keyword return between the curly brackets, a plus 2, returning in this case the the number produced by the expression a plus 2 must be an integer to match the return type. So whatever you return must match the return type. If your method returns nothing, in other words, if it does some processing and returns nothing, we say it's void. And here's some examples of additional return types. And I know I did this last class, but I'm going to have to do it again because I made an error in the slide. So this is actually a good thing. Whenever you have a return type, you'll notice that this method does not return. So let's go ahead and even make a point here that printing to the screen is not returning. So it's inevitable. I'm my world's worst proofreader, and believe it or not, I actually used to have a job proofreading. That didn't last long. All right, so let's look at the first one again with the corrections made. Public static void. The return type of the first method is now void. Notice that when I have the keyword void there, I actually leave out the keyword return, which is very important. And since you saw me actually remove the keyword return to correct the method, hopefully it's a little more sticky in your brain that method, if there's no return, then the return type must be void. It just means, hey, this method returns nothing. And remember that in this case, printing to the screen is not returning, so that's legitimate. In the second program down, I've changed the return type to be of type double. And notice that now when I return a plus 2.0, it's going to generate a double value. So again, whatever follows the keyword return must match the data type indicated by the return type. If the return type is void, then your method should not even have the keyword return in it. And as we look through code, we'll see this a little more. The final thing, or well, the next thing in our list here is the name of the method. Every method gets a name. The Java convention is to lowercase the first letter. Basically, naming methods follows the same rules as naming variables. So make sure the one thing is that when you name methods, you give them descriptive names. And I think you'll see in all of my examples, I've used very descriptive names for my method. Finally, we have the parameters. If your method accepts any type of input, that input is indicated between the parentheses. Your method may or may not accept input for processing. In this case, my method accepts a single parameter of type integer, and basically what I'm doing is declaring a variable, in this case called a, which is a really bad variable name, but it fit on the slide. Why am I declaring a variable called a inside of that set of parentheses? Because when this method is run, any value that I pass into this method as a parameter will get stored in the variable a, and then that variable a exists for the life of the method. So anytime inside of that method that I access the variable a, I have the ability to access whatever value the user entered into my method. And if you think of a method like a ride at Disney World, or if you think of it like a roller coaster, right? The roller coaster is a closed ride that has a bunch of cars that travel along the tracks, and then when those cars stop at the line, everybody loads in to the car, and then they get sent around the roller coaster for processing, and then they're let back out. Think of that variable a as the car that rides a value through your method. All right, same thing as you load into that method, or that variable a, your value gets copied into it, and then anytime you want that variable inside of the method, you access that variable. So this method accepts a single variable. Here's what it looks like on top if you have a method that accepts no parameters. Here's just a really simple method that returns pi. Pi is a double, 3.14159. So notice the return type is double, and the return statement actually returns a double. But notice because getPi doesn't do anything but return the value of pi, I just have two parentheses with nothing in between, because this system, this small method, accepts no input. On the following method called atom, I'm going to add two numbers. Notice it accepts two integer values and returns an integer. The first variable I declare is called a. The second variable I declared is called b. So when a user actually utilizes this method, the two values they pass in will get stored in variable a, stored in variable b, and then notice I add the value stored in a and b and return that. So multiple method parameters are separated by a comma. There is really no limit to the number of parameters a method can accept. I'm assuming it's probably like 255, but after about 5 or 6, things start to look really ugly. So at that point, we might need to consider. We'll actually write some methods this week that accept 4 parameters, and you'll see that it gets a little bit ungainly. So this is what it looks like when you have multiple parameters and no parameters. The final piece to look at between the curly brackets is your actual program. I'll call it the implementation of the method because that's the more proper term here. So when you implement your method, you're actually writing the code between the curly brackets. And in this case, this is where you write your mini program. There's no limit to the size of a method. A method can be anywhere from one line, like we have here, to a bazillion lines. Think of a big number. Methods can be enormous or they can be tiny, but I will recommend that smaller units of code are easier to write, are easier to debug, and are easier for you to understand. Now, there can be a case where you reduce your code to an amount where it's too small and you have too many methods, and that's a balancing act that you kind of have to learn as you code. But remember, smaller is always better. Single line methods are fine. Million line methods, probably too big. I think when you get over a couple hundred lines, you're probably starting to think, okay, do I really need this much code, or can I break this down into more methods to help me out? If we were to visualize methods, we've been looking at the implementation of this method moving forward, right? And we've written these methods, and we know what's happening inside of these methods. But think about methods we don't know, like println, or like I said, the POW method, the power method that raises something to a power. These are methods that are like black boxes to us. We don't know what happens inside. It's very much like our ATM machine. All we know about working with ATM machines is that we need to put in a PIN number, we need to put in an ATM card, and then that input goes into some, black electronic box that we can't see inside of. Again, there might be hamsters in there just handing out money, and then the output is money. And we really don't care how we get the output as long as we provide the correct input and it provides the correct output. So in this slide, what's important to note is that we really want to think of a method as this box that really nobody else can see except the person who wrote what's inside the box. So for you see inside the method, but if you were to give this code to your friend, they would just want to use the method. They wouldn't care how you wrote it. As long as you provide the input of 7 and you call the add2 method, it should return the output of 9. And that's really the way things work. You put gas in your car, you step on the velocity pedal, and you move forward at speed. You don't care what happens in between with the transmission and the carburetor or the fuel injector, and what the engine does. You just want to provide a specific input, let the system process it, and provide a specific output. And again, just to point this out, you don't need to know what's happening inside of the add2 method. You just need to know that when you call add2, when you call dot equals, that it does what you want it to do. Give it the appropriate input, you get the appropriate output. A couple other things that we'll talk about is that variables declared inside of methods are only visible inside methods which they are declared. This also includes variables declared as input parameters. So let's go back and look at this virtualized and visualized method and bring the pointer into this a little bit. This variable, int a, I've declared the name of the variable to be a. It stores of data type integer. Only exists inside of these two curly brackets. So when this method is run, this variable is created, it's utilized in this method, and as soon as this method is done executing, the variable a is destroyed. So it truly is a black box system. It's highly abstracted, and there's encapsulation occurring here in the sense that this method is like a brick fortress, right? It's like the city of Carcassonne that's got a wall around it, and nobody can see into it, and anything that you create or utilize in that method is not visible to anything outside of it. So think of it like a castle. If you want your methods to see other variables, you need to declare them outside of other methods. So let's go ahead and switch over to JGrasp here and actually write a little bit of code so we can see this happening. So I've got a piece of programming written here, and I'm going to go ahead and just add a method. In fact, we'll just write the add2 method. Public static void. We want to return int add2, and it accepts a single parameter. And I'll try to be consistent. Return a plus 2. Now, where in my code did I declare my method? Well, first of all, notice this is my method declaration. This is my main method. Notice that this is separate from my main method. And your main method is a method. Your main method is where the program knows where to begin running. So in other words, if you had multiple methods or you have multiple class files and you run a program that has many, many thousands of files, the JVM looks for the main method as the entry point to the program. It says, hey, where's the main method? That's where I always start. So this is really the starting line to your program. What I'm doing now is writing a little mini program that I want to run from within my main method. Notice that all of these methods are declared between my main class declaration, so my methods lecture. And now what I'm going to do is I'm going to declare an int variable called answer, and I'm going to call the add2 method, and I'm going to pass in the value 7. And then what I'll do is print out my answer. Now, I access or call my methods that I create inside of my main method. What this means is this variable a only exists inside this method. When I make the call to this method, the program is actually going to go ahead, jump down to here, run this bit of code. Once the value is returned here, it's going to go back into your regular main method and continue. So anytime you call a method, it's like saying, hey, go ahead and you do your job, and I'm going to wait, and until you're done, I'm not going to go anywhere. So whenever we call a method, the program basically redirects itself to the other little program and waits for it to, if it needs to return a value, return the value. So let's run this. And at the bottom of the screen, we get the answer is 9. So we call the add2 method, we pass in the parameter 7. 7 is stored in the variable a. We then add 7 plus 9. This value is returned, which means we can then assign it to a variable called answer, and then we can go ahead and we can put answer in here. Guess what? We can also call this directly. And we'll say like this time with no variable it is, and we'll pass in 15. So notice this time I'm going to call the method directly. It's still going to return a value, in this case 17, but that value 17 will be immediately concatenated to the string and immediately print to the screen. Let's run it. And notice that the first time I get answer is 9, the second time I get that it's 17. Notice that we're calling add2 without there's no dot operator. We don't say like anything besides this. We're just calling the method. And the reason why we can actually do that in this code is because this method is declared inside of this file. And in the future, if you were to declare methods in other .class files, there's different ways you can handle that. But because we're doing this very procedurally, we're actually capable of having the method called just by its name. Notice you also can't have you can have multiple methods with the same name, but don't do that for this week. We'll talk about how to actually go about doing that later on. Oops. Now let's jump back to Keynote and continue. So a couple of things. If you want your methods to see other variables, you need to declare them outside of your method. All right. So in other words, in our previous code, anything inside of our add2 method only exists inside of our add2 method. What if I want to write some code that actually deals with some variables? Well, let's write a method called initialize stuff. And let's say I want to initialize stuff to set my name variable to JSON. Well, where does this name variable come from? Well, all I want this method to do is set up some of my variables. Well, if you want a method to have an effect on a variable inside of your program, you need to declare those variables at the class level. In other words, notice I declared public static string name inside of my class, but outside of all of my methods. So here's a real weird thing. If you declare a method inside of if you declare a variable inside of a method, that variable only exists inside of that method. Think of like a castle again. If you're standing on the outside of a castle, you can't see anybody in that castle. You just see a brick wall. But if you declare the variable outside of all your methods, then any method can actually see those variables that exist outside of them. So it's kind of like the guard standing at the top of the castle tower looking out. If you're inside the castle and looking out, you can see everything around you. So the reason why I can assign the value JSON to the variable name is because notice that that variable is declared outside of all my methods. This is reinforced in the reading, and it's reinforced in all my code values. And if we run this, notice I don't get an error. Oh, I get an error because I put return type int. Notice there's no return keyword here. It should be void. And it's successful. If I want to now, I can take a look at how this works. Then we'll call initialize stuff. And then what we'll do is run this again. This might not compile. So the first time I'll print name, there's be nothing in it. I'll call initialize stuff, it'll add my name to it, and the second time we should see my name. So notice the first time I call name variable is, it prints out null. Why? Because I declared the variable name up top, but I never put a value into it. I declared it but never initialized it. Then I called the initialize stuff method. The initialize stuff method took the value JSON and stored it in name. And then when I ran that same line of code again, there was a value in that variable, and it printed it out. And again, now you'll see it with some spaces, so it looks a little better. So this is a little bit of code. I'll post this with the lecture so you can play around with this. So again, remember, any variables declared inside methods are only visible inside the method. Any variables you declare outside of methods are visible to everything. This is called variable scope, by the way. What is the scope of the variable? Where does it exist? And again, something we can talk about more as we move forward in the course and in other programming courses. A couple of things to keep in mind is when you pass a value into a method, that value is copied into the method parameter value. You really don't have to worry about this when passing primitives like characters, ints, and floats. But just remember that when you store an object into a variable, what you're actually storing is a memory address for where to find that variable. So when you pass an object into a method, you're actually passing in the memory address of that object. So here's the real rule of thumb. If you pass a primitive piece of data into a method, you're dealing with a copy of the data. If you pass in an object, you're actually passing in the original object. So just think of it in sense of, do you really, really, really want to mess with the original object? Because once you make changes to that object, you won't be able to go back. There's no undo. So it's just an important point for you to think about, and I've got some notes about that in the code as well. Again, just stressing the fact that variables declared inside methods only exist inside the methods, and they're destroyed when the method is done running. Later we can talk about the call stack. There's some definite implementation features as to how this works that would be important for you to learn. Usually we cover that in 111b in the next course. Remember that if a method returns void, you should not have a return statement inside your method's implementation. Void means there is no return statement inside your method's implementation. Static methods can really only modify variables that are also declared as static. So any variables that we're dealing with this week must be declared as static, and you can see that in my code example. That up top, when I declared my string name, and I declared it outside of all these other methods, I did declare it as static. If I get rid of that and recompile, I'm going to get an error that says, hey, a non-static variable name cannot be referenced from a static context. So the compiler will remind you. This week I'm going to just say you need to declare your methods static if you want them affected by static variables. Later on we'll talk more about the why you want to make them static. But at this point, just know you have to do it. And that's it for the lecture. If you guys have questions, there's this code file, and then I've also uploaded a very, very detailed code file that I think you should take your time. And the focus this week is reading code. So read the book and read the code. Play with the code. You can't break the code. Well, you can, but you can always come back and re-download the files and work with that new file again. So you really need to spend time reading and playing with this stuff to understand how it operates, and try to ignore some of the nuances of working with static and why we exactly do that. And then next week, as we get into objects and building our own classes, we'll more likely, we'll in more detail define that. We won't go into it 100%. If you're curious about why that is and you're enjoying programming, then yeah, you want to take CIS 111B, because in that course we do all types of object-oriented programming, and we come to the deep secrets related to a lot of these questions that we have in this course.